Okay, ma'am. So welcome to the 30th class of our computer architecture and organization. So in this class, we are going to discuss the concept called handling the multiple devices. In the last classes or last previous classes, we have discussed about what is meant by an interrupt and all these things, right? So here we are considering or we are discussing about handling of a multiple devices. One second. So, welcome to the 30th class of our computer architecture and organization. In this class, we are going to discuss about the concept called handling multiple devices. Okay, so in the last class, we have discussed about what is meant by interrupt, how an interrupt can occur. Okay, software interrupts, hardware interrupts, like that we have discussed. Okay, and what are the series of actions that the processor will take place when an interrupt occurs. That means it will go to the particular interrupt service routine. While going to that particular interrupt service routine, what is the thing it is going to do? It will place the contents of the flag register and code segment, insta for program counter, all these things it will place in the stack, isn't it or not? Whenever it will come from the interrupt service routine, it will just take those values once again. Okay, next, now the concept is handling the multiple interrupts or handling the multiple devices. See, as we have discussed previously, that if you want to have a system, that means any computer means it is not only a processor. Along with the processor, we need to connect various input devices and output devices, so that then only it will work. If I have only a processor of i7 which is of i7 or i5, and I don't have any other components like monitor, keyboard, mouse or something, there is no use, isn't it or not? Though my processor is an advanced processor with all the features, without these input devices, output devices that are connected to it, I can do nothing with a only processor, isn't it or not? Okay, so here the concept is so by default, that means our processor is going to be connected with different devices, or simply to say, different input devices and output devices are going to be interfaced to our processor. Along with this input device and output devices, we will interface even the external memory device also. Okay, so all these devices are going to be interfaced to our processor. Okay, and see, all these devices wants to do, every device is dedicated for a specific work, isn't it or not? If I have a keyboard, its main task is whatever I will enter, the text that should be placed, that should be it should receive the text what I am entering. That means if I enter some A, the keyboard has to transfer the data. Okay, and mouse is there. Mouse has some predetermined operation, moving from one place to another place, or clicking or selecting some data or something. Okay, so it is its separate task. Whereas printer has separate task, scanner has separate task, monitor has separate task. That means we have different IO devices which are having, each device having its unique task. Okay, and as we have discussed previously, whatever the task a device needs to be performed, okay, it can perform only under the supervision of the CPU. That means it will perform only with the permission of a CPU. Without the permission of a CPU, it is not going to perform any task. Okay, so here what is the problem means, at a time multiple number of devices can ask the processor to give access to do their work. That means at a time a keyboard can ask the processor to do its work. At a time a printer may ask the processor to do its work. At a time a monitor may ask the processor, may ask means may request. All they don't what we will call argue, they all request the processor, because processor is the superior. Okay, that means at a time multiple number of devices may ask the processor to execute something or to help them. Okay, so but we have only one processor. The processor cannot handle all the things at a time. It can handle only one device. Okay, so now we are going to discuss this concept only, how it is going to handle the devices, because at a time multiple number of devices may ask the request, like that there will be a multiple number of issues that may arise. What are the issues that we will get while handling the multiple devices, and how can we overcome these issues that we are going to discuss? Okay, so what they have given, let us consider a situation where number of devices capable of initiating interrupts are connected to the processor. That means here multiple number of devices are connected to a processor. Multiple number of devices are connected to a processor. This is the first thing what they have told. Several devices may request interrupts exactly at the same time. That's the thing now. See, we have several input and output devices. Okay, so there is a possibility that many of the IO devices may request for an interrupt at a time. Many of the input devices or many of the output devices may request for an interrupt at a time. Okay, so several devices may request interrupt exactly at the same time. This gives rise to the number of questions. That means if several devices request for an interrupt at the same time, we can get a lot of problems or a lot of issues. What are the issues? First one is, how can the processor recognizes the device requesting an interrupt? How can a processor recognizes the device requesting an interrupt? Okay, this is the first issue. Given the different devices likely to request different interrupt service routines, how can the processor obtains the starting address of the appropriate routine? These are the two issues. First one is, at a time, if 2 to 3 devices are requesting an interrupt. Okay, so how can the first of all, what is the first problem is, think that a single device is requesting an interrupt. Okay, how can my processor will know that he is asking for my help? First thing, are you clear? How can my processor comes to know that the particular person is asking my help? That is the first thing. And the second thing is, given the different devices likely to require different interrupt service routines. That means, so here the two problems are, first one is, telugulo chepte ప్రాసెసర్ అసలు ఇంటరప్ట్ అనేవాడు రిక్వెస్ట్ చేస్తున్నాడు అంటే కీబోర్డ్ నన్ను రిక్వెస్ట్ నేను ప్రాసెసర్ అనుకోండి, కీబోర్డ్ నన్ను రిక్వెస్ట్ చేస్తుంది లేదంటే మౌస్ నన్ను రిక్వెస్ట్ చేస్తుంది నాకు పని చేసి పెట్టమని చెప్పి, నాకు ఎలా తెలిసిద్ది? ఫస్ట్ వన్. సెకండ్ వన్, ఇప్పుడు ఆల్రెడీ వీ హావ్ డిస్కస్డ్, అంతకుముందు మనం మాట్లాడుకున్నాం కదమ్మా, ఇంటరప్ట్స్ వస్తే ఇంటరప్ట్ సర్వీస్ రొటీన్స్కి వెళ్ళాలి. అన్నిటికీ ఒకే ఇంటరప్ట్ సర్వీస్ రొటీన్ ఉండిద్దా? ఉండదు కదా. ఇంటరప్ట్ సర్వీస్ రొటీన్ అంటే మెడికల్ షాప్ అనుకున్నాం కదా. అంటే ఇప్పుడు నాకు జలుబు వస్తే దానికి తగ్గ మెడిసిన్ తీసుకోవాలి. నాకు ఏదైనా కొంచెం ఫీవర్ వచ్చింది అనుకోండి, దానికి తగ్గ మెడిసిన్ తీసుకోవాలి. సమ్ డయేరియా, దానికి సంబంధించిన మెడిసిన్ తీసుకోవాలి. టైఫాయిడ్ ఒక రకమైన మెడిసిన్, మలేరియా అనదర్ టైప్ ఆఫ్ మెడిసిన్. అంతేగాని అన్నిటికీ ఒకే మెడిసిన్ తీసుకుంటే కుదరదు కదా. సో ఇక్కడ కూడా వీఆర్ హ్యావింగ్ డిఫరెంట్ టైప్స్ ఆఫ్ ఇంటరప్ట్స్ దట్ మే అకర్ ఫ్రమ్ డిఫరెంట్ డివైసెస్ అండ్ ఈచ్ ఇంటరప్ట్ హ్యాస్ ఏ యూనిక్ ఇంటరప్ట్ సర్వీస్ రొటీన్. మలేరియాకి ఒక టాబ్లెట్ ఉండిద్ది, టైఫాయిడ్కి ఒక సెపరేట్ టాబ్లెట్ ఉండిద్ది, లేకపోతే బాడీ పెయిన్స్ కో సెపరేట్ టాబ్లెట్ ఉంటుంది. అన్నిటికీ కామన్ టాబ్లెట్ ఏమి ఉండదు కదా. హియర్ ఆల్సో ద సేమ్ కాన్సెప్ట్. డిఫరెంట్ ఇంటరప్ట్స్ మే అక్కర్ డ్యూ టు ద డిఫరెంట్ డివైసెస్ లైక్ మౌస్, కీబోర్డ్, scanner, printer are like that. Okay, and every device has the unique interrupt service routine but not the same interrupt service routine. Okay, so here the problems or the challenges that are faced by a processor is, first of all, how can it identify that a particular device is asking it for interrupt or for its help to execute an interrupt? How can a processor recognizes? That is the first thing. Second one, though the processor recognizes and it tries to help, how can it help? That means, how can it locate the interrupt service routine of that particular interrupt? Okay, these two are the challenges that are to be faced by our processor. Okay, so the information needed to determine whether the device is, so how can I rectify these two problems is, the first problem can be rectified by using a concept called IRQ bit. IRQ full form is interrupt request. Okay na? So we are having a bit called interrupt request bit. This bit will be present in the each and every device. That means along with the mouse, that means when we go for an internal architecture or internal software of a mouse or keyboard, in every keyboard or mouse there will be a bit called IRQ bit. IRQ bit means interrupt request bit. Okay, so to determine whether the device is requesting an interrupt or not, it is available status register with a, which we will call IRQ bit. It is having a status register. Status register is nothing but a flag register, what we have discussed in the previous classes. Okay na? So in this status register we are having a bit called IRQ. IRQ means interrupt request. IRQ means interrupt request. So whenever this particular okay, so whenever this particular interrupt request bit is going to become 1, whenever this interrupt request register IRQ bit is going to become a 1, that means it is going to what you will call so whenever the IRQ interrupt request bit is there now, whenever it will become 1, that means what is the thing that is going to happen means a particular device is asking for an interrupt. Okay, whenever it becomes 0, that means it is not asking for an interrupt. That is the thing that is going to happen. Okay, so that will be determined by using IRQ bit, interrupt request bit. Whenever this bit becomes 1, it will ask for an interrupt. That means a device, some other device is asking for an interrupt. Whenever it becomes 0, that means no one is asking for an interrupt. Okay, so simplest way to identify the interrupt device is called as interrupt service routine poll. See, this is the phenomena. There is a concept called interrupt service routine poll. What does it mean? It means that the processor will go and check each and every device at a time, sequentially, one by one. That means our processor will go to the keyboard and checks its IRQ bit, interrupt request bit. If it is 0, that means there is no interrupt from the keyboard. Again, it will move to the IRQ bit of a mouse. Again, if the mouse's IRQ bit is also 0, that implies the mouse is also not having any interrupt. Okay, similarly, it will move to the monitor's IRQ bit. It will check for the scanner's IRQ bit. It will check for the what you will call speaker's IRQ bit. Like that, it will check all the IRQ bits one by one. This phenomena is called polling. Okay, polling means it will move from one device to one device, and it will check whether that particular bit is 1 or 0. For example, if it identifies that the IRQ bit of the printer is going to be 1, the IRQ bit of the printer is going to be 1. What does it mean? Now the printer needs to print some data, isn't it or not? The printer is requesting something means what does it mean? It needs to print something. Okay, it needs to print something. Okay, so that is the purpose of this one. Okay, so the first device encountered with its IRQ bit sets its devices that should be serviced. Okay, so it will check the devices like this. First, it will go to the keyboard, mouse like that, and if it observes that the keyboard bit is 1, then obviously it will service the interrupt of this keyboard. Okay, so this is the case, and another case is also possible now. That means, see, in the last example I have told only the keyboard's IRQ bit is 1, rest of the IRQ bits are 0 in the previous case. But there may be a case where 2 to 3 IRQ bits may become 1, where there may be 2 to 3 IRQ bits may become 1. That means IRQ bit of a monitor, IRQ bit of a keyboard, IRQ bit of a printer. Okay, in that case we have 3 IRQ bits which may become 1. That is also a case now. So what happens when that particular phenomena occurs? Means, see, the processor used to poll from one side to another side in a sequential manner. It has, because every device has one address, IP address or something. Similarly, whenever we connect all these devices together, okay, there will be some hierarchy of checking the devices. That means depending upon their alignment, there will. So what our processor will check means it will start from the first device, and it will go on checking the devices one by one. Okay, so whenever if 2 to 3 devices are having an interrupts, okay, first of all what it will do means whatever the first device that has this whatever the first device that is present or that is identified by this one, okay, it is going to be processed first. Okay, that is the concept. That means okay, so that means if more than 2 interrupts takes place, then our processor will execute the device which will be encountered by it first. That means it used to go on searching devices one by one. No? So whichever the interrupt that our processor will identify first, whichever the IRQ bit of which device our processor identifies first, that particular device is going to be serviced first. Okay, then only the next device is going to be serviced. Okay, after that the next device. So this is the phenomena of handling the multiple interrupts, handling of multiple interrupts. Okay, so that's what they have told. Simplest way to identify the interrupt device is to have a interrupt service routine poll, ISR poll. So polling means it will search one by one. Okay, the first device encountered with this IRQ bit set is the device that should be serviced. So So it will check our processor will check the device one by one, and first of all, which device's IRQ bit is identified by the processor as 1, that is going to be serviced. Okay. Next, the concept is vectored interrupts. As we have told in the previous classes that I will once again revise, an interrupt is a breakage to the normal flow of a program. Whenever an interrupt occurs, our controller or our processor will transfer from the main program to another place. That is called interrupt vector table. Interrupt vector table. In that particular interrupt vector table, there may be small subprograms. Those will be called as interrupt service routines, ISRs. Okay, this interrupt vector table is a medical shop, and the interrupt service routines are the medicines. Okay, there are different medicines for different diseases. Okay, depending upon your problem or depending upon your disease, you need to take the right medicine, but not the medicine whatever that is that comes to you or whatever that is identified by your eyes. You need not take that one. You should not take that one. You need to take the medicine which is required to service that particular thing only. Okay, so that is the concept. So it will be referred as interrupt. So interrupt service routines. All the interrupt service routines are present in the interrupt vector table. All the interrupt service routines are present in the interrupt vector table. Okay, I've told you now. Okay. Okay. So now we are discussing the concept called vectored interrupts. What is meant by vectored interrupts? Means, see, in the last class, that not in the last class, in the previous slide, what we have discussed that the processor is going to search. Polling means searching. It will go to the each and every device and it will search whether the bit is 1 or 0. Okay, if the IRQ bit is becomes 1, then only it will what will call execute. It will execute that particular interrupt. That means now the processor is going to the processor is moving to each and every device and it is searching for that, isn't it or not? The processor is what you will call, now the processor is going and it is searching to each and every device. As we have told that processor is the superior person, isn't it or not? Processor is the superior person. If the particular superior person, if he is moving to each and everybody and searching, is it the good thing? Is it the good one? No, not at all. Na ఇప్పుడు అతనే కింగ్ లాంటి వాడు, లేదంటే ఓకే అతనే పోయి అందరి దగ్గరికి పోయి మీరు చేశారా అంటే కుదరదు కదా. యాక్చువల్ గా జరగాల్సింది ఏంటి, అందరూ అతని దగ్గరికి రావాలి, బికాస్ హీ ఈస్ ద సుపీరియర్ అథారిటీ. మామూలుగా అదే కదా కాన్సెప్ట్ జరిగేది. బట్ ఇతనే పోయి వాళ్ళ దగ్గర చెక్ చేసుకోవాలి అంటే కుదరదు, బికాస్ he have different works along with this one. He should take care of entire things. ఓకే, అందుకని అతను వాళ్ళ దగ్గరికి వెళ్తే కుదరదు, వాళ్ళే తన దగ్గరికి రావాలి. So for that purpose, we have introduced a concept called vectored interrupts. Okay, so that's what they have given here. See, to reduce the time involved in polling of a device, requesting an interrupt may identify itself directly to the processor. This is the thing. Here in this vectored interrupts concept, we don't have any polling concept. That means the processor need not go and verify whether there is an interrupt or not on each and every device. The processor don't go to the each and every device address, and it is not going to address, or it is not going to verify whether an interrupt is present on that particular device or not. Okay, here now what is the thing that is going to happen means, if a particular device is requesting for an interrupt, that will be identified directly by the processor. The processor won't go there. Okay, there will be a mechanism so that if a particular device requests for an interrupt, that will be identified directly. That phenomena is called vectored interrupt concept. Okay, so the processor can immediately start executing the corresponding interrupt service routine. A device requesting an interrupt may identify itself by sending a special code to the processor. See here, what is the concept means, here the processor don't move or it won't waste its time. If a particular external device requests an interrupt, okay, it will directly intimate to the processor. It will directly send a special code to the processor, so that the processor will come to know that particular X device or Y device or Z device is going to trying to execute the interrupt or handle the interrupt. Okay, then the processor can immediately start executing the corresponding interrupt service routine, isn't it or not? For example, if the keyboard requests a processor by using a special code that it needs the help of the processor to execute the task, then the processor will immediately execute its interrupt service routine so that it can get over from that interrupt. So this is about the vectored interrupts concept. Here the main advantage is, in the previous polling concept, the processor needs to poll each and everything. It needs the processor needs to go to the interrupt service IRQ bit of each and every device, and it needs to check, and whenever the device IRQ bit is 1, then the processor will needs to execute that particular interrupt that is required by that particular device. But here we don't we have lessen or completely reduce the burden on the processor. Here the processor won't go to different devices. Okay, what is the thing that is going to happen here is the processor will be in its state only. Okay, if any device requires an interrupt, if any device requests for an interrupt, then automatically they will ask the processor by sending some special signals. Here they have written a special code, by sending special code to the processor, so that I need some request, please help me, like that. Okay, so depending on that request, the processor will immediately respond. This phenomena is called vectored interrupt. This will reduce the time. That means it will increase the speed of the operation. Okay, so that is the thing. So that's what we have written now. A device requesting an interrupt can identify by sending a special code to the processor. This enables the processor to identify individual devices even they were share single interrupt request lines. So this special code is there now. This special code is different from different devices. The code is different from processor for a keyboard. We have separate special code for mouse, CPU, not CPU. We have special what you will call special code for keyboard, special code for mouse, special code for printer, special code for scanner, like this. Okay, so what is the thing that is going to happen means, so if any device sends that special code, then the particular device can easily identify that special code. Okay, if a particular device can send this special code, then that means if a mouse sends this special code, then the device can easily identify. Device means then the processor can easily identify that the mouse requests the interrupt. ఏం లేదమ్మా, ఇక్కడ స్పెషల్ కోడ్స్ అనేవి ఒక్కొక్క డివైస్ కి ఒక రకంగా ఉంటాయి. ఏ రెండు డివైస్ కి స్పెషల్ కోడ్ సేమ్ గా ఉండవు. ఓకే, ఇప్పుడు ప్రాసెసర్ కి ఒక చోట నుంచి స్పెషల్ కోడ్ వచ్చింది, అది చూసిన వెంటనే ప్రాసెసర్ కి అర్థమైంది ఏంటి అది ప్రింటర్ పంపించింది అని. లేదు ఇంకో స్పెషల్ కోడ్ వచ్చింది ప్రాసెసర్ కి ఇంటరప్ట్ కోసం, ఆ స్పెషల్ కోడ్ ని చూసిన వెంటనే ప్రాసెసర్ కి అర్థమైంది అది మౌస్ పంపించిందని. బికాస్ ఎవ్రీ డివైస్ హ్యాస్ ఇట్స్ యూనిక్ స్పెషల్ కోడ్. ఓకే, whenever this particular device sends this special code, automatically the processor will come to know that it needs to handle the interrupt. Along with that, it will also come to know that which device has sent that particular interrupt, because every device has an unique special code. Okay, so that is the thing that is happening. Okay, and see here what is mean, and one more thing we need to discuss about the vectored interrupt is, see, the code supplied by the device may represent the starting address of the interrupt service routine. See, this is the thing you need to learn. If the address is present in the interrupt itself, that means if the special code what they are sending, okay, in that code itself there is an address which is the starting address of an interrupt service routine. What is meant by an interrupt service routine? I have discussed previously. We are having an interrupt vector table which is called medical shop. In that medical shop we are having multiple number of interrupt service routines. Okay, so interrupt service routines are nothing but the what you will call tablets. Okay, so if a particular device, while asking its interrupt itself, it is giving its starting address of an interrupt service routine, such kind of interrupts are called vectored interrupts. That means మనం మాట్లాడుకోవాలంటే, నాకు ఫర్ ఎగ్జాంపుల్ కొంచెం ఫీవర్గా ఉంది. ఓకే, నేను మెడికల్ షాప్ దగ్గరికి వెళ్ళా, నాకు ఫీవర్గా ఉంది అని చెప్పా, అది నా ఇంటరప్ట్. ప్లస్ దాంతోపాటు నేను ఏం చెప్తా, నాకు క్రోసిన్ మెడిసిన్ ఇవ్వండి, క్రోసిన్ ఏదో ఇవ్వండి అని చెప్తా. అంటే నా ఇంటరప్ట్ ఏదో నేనే చెప్తున్నా, నా ఇంటరప్ట్ సర్వీస్ రొటీన్ ఏందో కూడా నేనే చెప్తున్నా. నాకు పలాని పలాని క్రోసిన్ టాబ్లెట్ ఇవ్వండి. ఓకే, లేదు సంథింగ్ ఐ హ్యావ్ సమ్ అదర్ ప్రాబ్లం. ఓకే, కొంచెం గ్యాస్ట్రిక్ ప్రాబ్లం ఉంది అనుకోండి, నేను వెళ్ళి ఏమంటాను, గ్యాస్ టాబ్లెట్స్ ఇవ్వండి, దానికి ఏదో పేరు ఉంది కదా, గ్యాస్ టాబ్లెట్స్ ఇవ్వండి. సో ఐఎమ్ ఆస్కింగ్ దెమ్ విత్ నేమ్ ఇట్ సెల్ఫ్. ఓకే, క్రోసిన్ ఆర్ సంథింగ్, ఆర్ ఇఫ్ నాట్ ఐ వాంట్ సమ్, ఐ హావ్ సమ్ లిటిల్ బిట్ ఆఫ్ హెడేక్ ఉంది, ఓకే, గివ్ మీ సమ్ పతాంజలి బామ్ ఆర్ జెండు బామ్, లైక్ దట్. అంటే ఇంటరప్ట్ ఏదో నేనే చెప్తున్నాను, ఇంటరప్ట్ సర్వీస్ రొటీన్ ఏందో కూడా నేను చెప్తున్నా. సచ్ కైండ్ ఆఫ్ ఇంటరప్ట్స్ ఆర్ కాల్డ్ వెక్టర్డ్ ఇంటరప్ట్స్. అదే ఇప్పుడు నాకు కొంచెం టైఫాయిడ్ ఏదో వచ్చింది అనుకోండి, నాకు కొంచెం ప్రాబ్లమాటిక్ ఉంది, లేదంటే ఏదో సంథింగ్ వేరే ప్రాబ్లం వచ్చింది, టైఫాయిడ్ ఆర్ సంథింగ్, మలేరియా, కొంచెం మలేరియా అన్నారండి, టాబ్లెట్స్ ఇవ్వండి అంట. హియర్ ఐఎమ్ జస్ట్ టెల్లింగ్ మై ఇంటరప్ట్, బట్ నాట్ ద ఇంటరప్ట్ సర్వీస్ రొటీన్. Whereas in the first two cases, when I am feeling with a little bit of fever, I will directly ask them for a paracetamol tablet, or if required, I will tell the crocin or a brand name also. Okay, so that is called vectored interrupt. Along with the interrupt, I am specifying my starting address of an interrupt service routine. Okay, so that is about this class. Next class we are going to discuss about the remaining topics. Okay.